Okay, I think this is it. We're pretty much ready to put everything together into one nice little package and have some sumo battle going on. When we look at the code, you can see basically I've just combined everything we've done. I still have these variables here, the left and the right value, which are coming off of the photoresistors. But now I have copied and pasted in those two booleans, those two true-false statements from switch 1 and from switch 2. This remains the same. Notice here I changed this subtly. Okay, the right and the left no longer have the same time increment. That's because if the robot finds itself in a corner, you don't want it just sitting there going to the right and to the left, back and forth and back and forth and back and forth. So what you do is you want to make it unbalanced. That's a simple way of getting it out of there. Of course, there's lots of wonderful logic ways to do it, but this is the simplest. Just make it unbalanced, so eventually it turns, in this case, to the right more than it does to the left, and it'll get itself out. All of this remains the same that we've done in the past. I still have this here, but actually I don't need it because I actually deleted all that, but we'll deal with it later. And, well, I mean, what am I doing? Let me get rid of it. I don't want this serial. Okay, gone. And so what do? Well, we come into the main loop. It checks those two analog sensors, those two photoresistors. And then it checks to see whether or not those two mechanical switches, these two switches, are touched. And it goes through the exact same thing we've done before. If switch 2 is absolutely positively set to ground, well, then I want you to turn right. If switch 1 is absolutely positively set to ground or false or 0, I want you to turn to the left. All right, and then we're going to go ahead and check the analog sensors. If the right value is greater than 400, same thing we did within the rank and line following. Turn left. I can get rid of this because I'm going to just remove the serial stuff. Just makes the robot a little too slow. We want it to be able to move quickly here. And we have these LEDs to light up. Oh, and of course I still have this port B here, lighting up those two LEDs so we can see whether or not they're triggered. And last but not least, if neither of the sensors find the black line, well, let's just move forward. So what should happen then is if two robots are in the arena at the same time, they're going to go ahead, and if they bump into each other with either of the feelers, they're then going to steer toward the other robot and try to push it out. I'm actually going to load this new piece of code we just wrote. There's a few edits onto my processor. Okay, now off it goes. And okay, and I'm going to set this robot aside because while you weren't looking, I built another one. Okay, so that way we can actually see the sumo. What I do want you to notice, I did make a minor change, certainly a very convenient one. When I plugged in the Pro Mini, I plugged it in slightly further back. Okay. The reason being is I realized, boy, it's really annoying to unplug and plug in that little wire that goes to 9 volt. Now what I've done is I moved it one back so that way I can put in a switch, which if the 9 volt is hooked up to the center pin, okay, and the switch is in this position, it just goes nowhere, the electricity goes nowhere, and if the switch is in this position, it turns it on, okay. So now we have two robots. There's another difference here. This robot, and I'll show you how to do this in another sort of accessory video, uses infrared. So when you see this one on the mat battling the other one, you're not going to see any light come out of this because it's using infrared sensors instead of the bright ultraviolets. I think that's basically it. I hope everything makes sense. We've talked about all the other stuff. and I'm going to end this one and attach a video of some sumo battle, and I hope you enjoyed it. Thank you.